Today we are going to be looking at three-dimensional geometry. And so I wanted to just kind of start with a little introduction for those of you who aren't completely familiar with this. You may have done some of this in the past before. We're going to be talking in this class about prisms, pyramids, cylinders, cones. We really aren't going to do too much with spheres, but they are part of this, and I've kind of got to cut this down a little bit just based on time and the things that we have to cover. So today we're going to start with prisms, pyramids, and cylinders and cones, just kind of identifying them, and then we'll begin working through with some math. All right, so let's kind of define what these are. So these right here that you see are classifications for what we call solids. So three-dimensional shapes in geometry, we call them solids, okay? And so these solids fit these classifications, okay? Now the way this works is if you have a solid that has two bases to it, and those bases are congruent and parallel, then you have a prism. All right, hit the brakes, bases. Okay, now we've had this word bases before, and you're going to see this word pop up, and it's going to have different meanings. Kind of like my kids went outside to play. I took my wife to go see a play. Same word, two totally different meanings, right? And we're going to have base in this lesson have two totally different meanings, and you're going to need to be able to determine which base are we talking about. This base right here is the base of the solid. Okay, and we call this capital B base, and you'll see why I call it capital B base in a little bit. So this is the base of the solid. So what I want you to do is identify with your finger right now the two planes of this solid that you think are parallel and exactly the same in shape and size. Identify them with your finger, put your finger on them where you think they are, okay? You should have identified this triangular top right here and this triangular bottom right here. Good? Okay, those are your bases. So what we're going to do is, with our two different colors, we're going to highlight our bases. So I'll show you how I do this. Like, I just kind of go around the edge here, and then I use like a little stripey pattern. That kind of makes it stand out a little bit. And then on the other one, I'll use a different color, and then I can even use like a different stripey pattern, and that really sort of helps it kind of stand out. Okay, so these are the bases of our solid. Okay, so if we have two bases, then we have a prism. All right, well, if we have a solid that has one base that contains faces that meet at a point, then that solid is called a pyramid. Prisms have two bases, pyramids have one base. Okay, so put your finger right now where you think the faces come to a point. Where do you think the faces come to a point? You should have put your finger right here. Yes? Good. Okay, so if this is the point at which the faces meet, then by default, that becomes a face. And this becomes a face. And the one on the back side here becomes a face. And that leaves this guy right here, which is the base, capital B base of the solid. Let's highlight it. All right, good. Okay, good so far? Now, when we name these shapes, okay, it's kind of like a first name and a last name. The last name is the classification they fit into, and the first name is the shape of the base. So in both of these cases, we have triangular bases, right? But because we have two of them, we call this a triangular prism, whereas this one is called a triangular pyramid. First name, last name. The first name is the shape that is the base. The last name is the classification that it fits into. Okay? Triangular pyramid, triangular prism. We can have squares and rectangles and pentagons and all that stuff, all right? Different shapes. Okay, now, a cylinder is just a prism with circular bases. Highlight the bases of the cylinder. Should have highlighted those two, right? So this is kind of like one of those musical artists that only have one name. Like in my world, it would have been like Cher or Madonna. I guess you guys is Beyonce, is that right? Right? Yeah, one namers, right? This is a circular prism right? But we don't call it a circular prism. Oh, I got you. You guys know who Slash is? There's a lot of rock people with the big black hair. Used to play for Guns N' Roses. You know what I'm talking about? Nobody has no clue. Okay, all right. All right, I found out last name. His name is Saul Hudson. That's his real name, Saul Hudson. But he goes by Slash. This is a circular prism, but it goes by cylinder. Got it? One namer, okay? All right. So then a cone is just a pyramid with a circular base. Like that. Yep.
Since for cylinder, they also have the bases which are congruent and parallel. So is cylinder is part of the prism?
Is what part of the prism?
Cylinder.
Yeah. Cylinder is a prism. Exactly. Yeah, see right here. So it is a prism. It's just circular base. So when it has circular bases, then it's just called a cylinder. Okay. And then, of course, we have our sphere. Here, let's actually underline our circular base for our cone. And then when we have a sphere, like I said, we're not going to talk about this in great detail. We'll see what our timing is like. But we can take a slice out of that sphere. That's kind of like the base. Our spheres are three-dimensional circle. All right, we good? Everybody cool so far? All right, so here's what you're going to do right now. I'm going to give you about 4 minutes. And what I would like you to do is I would like you to highlight the bases for all of these shapes. And I want you to name them with their proper 2 or 1 name that goes with that particular solid, okay? Now, if you're unsure on some of them, feel free to use your regular pencil. That way, if you want to erase it or not, that's fine. Or if you think you got it, then just base and highlight away and write down the names, okay? All right, I'll give you about 3-4 minutes to do this. We'll see how you're at. Ready to go. Let's take a look, see where you're at, see how you did. Here's what you should have come up with here. Here, we'll go with the first 6, and then we'll look at the bottom 6 so I can zoom in a little bit. Again, you're looking for the bases are the shapes that are parallel and same size. Okay, parallel and same size. And with the pyramids, you know the base because it is not part of the point to where the faces meet. Yes, sir.
Everything will represent on the 6.
Yes.
The square side to the...
It could be, so in this particular case, it could also be these sides here. It could also be the front and the back. So as long as you pick 2 and go with it, that's fine on that one, yeah, because that one has multiple options. All right, any questions on these? All right, let's take a look at 7 through 12. So 7, the trapezoid one, that's one that you're going to see quite a bit of, and that's a pretty tricky one. But again, if you recognize the trapezoid shape, and you're like, well, that's a trapezoidal prism, or that's a trapezoid prism, then you should be able to find the base because you would just trace the trapezoid. And then you would know that it's the front and the back. Yeah, Pierce.
Number 8, I didn't realize it was like a square, but I thought it was rectangular. Like, would that answer still work?
For today, yeah. But, I mean, there is something in here that indicates that this is a square. These little lines right here. But we haven't really gotten to that in great detail. But for today, that's fine. All right, any other questions? You guys do okay on this? All right, good. Okay then, let's do some math. Key measurements we're going to be talking about with these solids are surface area and volume. Today we're going to start with surface area, then we're going to be looking at volume next week. So surface area is like wrapping paper, okay? If you wrap the present in the box, then you unfold the paper and you measure the paper, that's your surface area. So whatever covers the surface all the way around the outside of the shape. Now, you guys are going to be given a series of these formulas. You can see like this one here, and you can see like this one here, and then there's this one back here, okay? And so you're going to be given these formulas, and you're going to be expected to know them, okay? Now, I will give you some of that on the test, but you're going to need to know what shapes those go with. So like, for example, I might just give you this, or I might just give you this, and you need to know what to do with that, okay? And so you need to know which piece goes with what, okay? I may also ask you to explain certain things like we'll talk about today, like why is this a relevant shortcut for finding lateral area, and what is the lateral area, okay? And so we'll talk a little bit about that today. And so I may ask you to explain those questions as well, okay? All right, so let's start with the easy one. All right, so rectangular prisms, obviously this is pretty simple. We noticed this as we were shading. We've got all these different sides, right? So we've got the front and the back here. We've got the top and the bottom. We've got the left and the right. So we have these 6 sides. And common language, sometimes you see this length and width. I will oftentimes use base and depth. Those are usually more high school. Height is height, okay? Now this is the height where it meets another line at 90 degrees that we use to find the area of a flat two-dimensional surface, okay? That's that kind of height, but we'll have a different height as we move along. All right, so let me show you what I want to see for work from something like this, all right? It'd be pretty simple. So you're going to say the surface area is going to be 2 times plus 2 times plus 2 times, okay? There you go. Why don't you fill in the numbers that you think go in those spaces? Give it a try. Make sure you did that. Here you go. Do your numbers have to be exactly the same place mine are? No, they really don't, right? Because when we do this math problem here, and this one here, and this one here, we're going to get 1 plus blah plus blah, and we can switch the order of that around, and that's okay. What you do need, though, is all of the combinations of the 3 values that you see in the problem. Whether you call them length, width, height, base, depth, I really don't care, right? I'm really just interested that you get those in the right place. So we'll have one more step of work for our problem here where we say surface area is equal to, and then you're going to give me 3 numbers, something plus something plus something, and then you can give me your final answer where you say surface area is blah, 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 okay? Great question. We'll get there when we talk about the answer. How's that sound? Okay. All right, go ahead and finish this up and let's see how you do. Here's what you should have come up with right here, right? So again, these 3 numbers can be written in any order. I'm fine with that as long as you show me those 3 numbers. That shows me you understand where you're getting them from. And then yes, the answer is squared, right? Because we're adding areas together, right? So we're not multiplying. Multiplying is what increases our exponent. Okay, these are easy. Everybody good? This is simple, right? We don't need to do another one of these, right? Okay, good. Let's move on. All right, so now let's talk about all other prisms here. Let's talk about all other prisms. Okay, so for all other prisms, what we need to find is the lateral area and then the area of the 2 bases. So here's the lateral area. Watch up here. It is the non-base areas. So the sides of the shape that do not belong to the bases. That's what we call the lateral area, okay? And then, of course, you can see there's our capital B area of the base, and then we would have 2 bases in our formula. So if we find the lateral area, which is this H times P, and then we add that, the area of the 2 bases, we'll have the whole area, the surface area of the shape, okay? So let's talk about this H times P. So this H is H, the height of the solid. This H is H that meets another distance at 90 degrees on a flat 2-dimensional surface. Same word, 2 different meanings. My kids went outside to play. I took my wife to see a play. There are 2 different heights here, and you need to know which one we're talking about, okay? So this is the height of the solid. Okay. Now, a good way to think about this is it's the distance between the bases. So if you're looking for the height of the solid, you're looking for the distance between the bases. So if you can find the bases and then you can find the distance that separates those 2 bases, you've now found the height of the solid, different than finding the height on a flat 2-dimensional surface. Okay. All right. So let's talk about this question here. And we'll begin to work through this together. So our lateral area requires us to know the H height of the solid and then P, the perimeter of one of the bases. So let's highlight our bases first for this one. Let's start with that. So where are the bases? Find them and highlight them. Those 2 right there, yeah? What kind of a shape are we dealing with here? Triangular prism. All right, good. So then what is the height of the triangular prism? It is 16 units because that is the distance, or 16 meters, that is the distance between the two bases. All right, so we could put 16 here. And then we need the perimeter of one of the bases. Well, how do we find that? How do we find perimeter? Okay, add up the sides. So like 9 plus 12 plus, I don't know this one. Oh, it's 15. That's right. Because I could take this base and I could lay it on flat on top of that base, right? They weren't separated by 16 meters here, and they would line up perfectly, right? So I can use either measurement on the base to help me find the distances I need. All right, so what is the measurement of our perimeter? 36 units, right? And of course, that comes again from our 9 plus 12 plus 15, if you want to make it. Okay, so then the lateral area of this particular shape is 16 times 36, right? The height times the perimeter. Yeah, Arjun.
For the height, like, say that one of the sides of the triangle was tipped downwards and the base on the bottom was tipped upwards, that height would obviously be shorter than the one in the back. Right?
Those wouldn't be bases of a solid because bases of a solid are always parallel. Okay. If they're tilted like that, then they're intersecting. Those wouldn't be the bases. Okay, good question. So what is the lateral area? 576, and that's going to end up being meters squared, right? Okay, so I want to talk about something real quick with you because, for me, one of the things I like about math is understanding why certain things work. I don't say, like, here's the formula, memorize it, okay? But where I can, I want to show you some whys. So let's talk for just a second about why does this little height times perimeter trick work for finding 3 areas of this shape? How does that work? So let's do a little sidebar over here. And we're going to say, why does the lateral area formula work? Why is that a good little shortcut for us? Well, again, let's talk about what is the lateral area, right? Well, it's the area of the 3 non-base sides. So like, for example, let's take this front face right here. What math problem would I need to do to find the area of that front face right there? Yeah, I have to do 15 and 16, right? So I'm going to write it 16 times 15, right? That would get me that front one, right? Okay. How about this side over here? What math problem would we have to do to find that one? Anyone want to take a shot? Yeah, that'd be 16 times 9, right? Okay. So 16 times 9. And then if we wanted this side right here, so that's going to be 12 and 16, right? Okay, so plus 16 times 12. So those are the 3 lateral areas that we're adding up, right? So I'm going to do a little factoring here, a little Algebra 1 factoring. And I'm going to pull out a 16 from each one of those terms, right? So I'm going to do lateral area is equal to 16. And that's going to leave me with times 15 plus 9 plus 12. Like I'm undistributing, right? Like if I gave you this math problem right here and I said, hey, distribute this math problem, you'd go 16 times 15, 16 times 9, 60, right? Okay, so I'm just undistributing. I'm just going the other direction, right? But what do these 3 numbers added together represent for us in our problem? Yeah, that's the 15 plus 9 plus 12. That's the perimeter of one of the bases. And so that's why the lateral area formula works for us, right? We've got this 16 times 36 here. So just kind of, like to understand why things work the way they do. All right, good. So now that we have our lateral area, right? So now we can start working on putting together our surface area. All right, well, our surface area is our lateral area plus 2 times the area of the base. Okay, well, what kind of a base do we have? What shape is it? Triangle. Okay, what's the formula for the area of a triangle? Okay, its area is equal to 1/2 base times height, not the height of the solid. This is the height that sits on a flat 2-dimensional surface that meets another distance at 90 degrees. Different kind of height, different kind of h, right? Okay, good. All right, why don't you put the numbers in here and here that you think go where they're supposed to be. Go ahead. Put 9 and 12, right? Why 9 and 12? Because 9 and 12 sit on a flat two-dimensional base and meet at 90 degrees. So there's your area of your flat two-dimensional base. Okay. So we have 9 and 12 and a half is 54. So then we can put our area up here, and then we can say our surface area is 576 plus, what's 2 times 54? 108. Okay, good. And that gives us the total surface area of total surface area 684 what? Meters squared. Question, Quinn?
Yeah. So when we did this triangle formula, if we did like 12 times 9 and split it in half, would it be fine if we like skip the half part? Because we just multiply by 2 and
So what you're saying is because we take this and we divide it by 2 and then we multiply it again by 2, we still end up with 108, right? Mathematically, yeah, you come up with the same number. But no, I don't want you to do that. But let me tell you why, just so that you understand, okay? When you write your work like this, that shows me you understand that you're finding the area of a triangle, which helps me understand that you know that that's the base. When you write your work like this, that helps me understand that you know that there are 2 bases in the triangular prism. So yeah, we get back to the same number, but this is a more thorough argument as you're writing your essay out. And so that's how I'd like to see it. Does it make sense? Yes, ma'am. Yep, you got, I think you used one the other day, right? Did you use one the other day? No. Okay, all right. So go ahead. First one. Got it. So you just need to sign out using the red sign out up there. Okay. Good. Triangular prism. Everybody cool? Surface area? Okay. So we'll skip 5 for now. Let's do number 6. Go ahead and highlight your bases for number 6. Things I said, right? So those are the 2 bases right there. Everybody good? All right. Think you can do this one on your own? Yeah? Give it a try. Let's see what you do. Go for it. Should have come up with 1,587 feet. Who got that right? Let me see. Nice. Look at that. That's good. Nice job. All right. If you didn't get that, take a look and see if you can figure out where you went wrong. Was it in finding the area of the trapezoidal base? Was it in the height of the lateral area? Did you not double your surface area bases? Good? No? Questions? Okay. Well, I don't have time for everybody to copy everything down. I will post those answers, though, for you so that you have them to look at, John. But kind of just, the idea is just to do a quick glance right now. Yeah, Margo. So on a trapezoid, right, the 2 bases that we add together are the parallel sides. So now we're talking about the flat 2-dimensional surface. That's this length and this length. Those would be the bases of the trapezoid. Okay? All right. Okay, so number 7 is another trapezoidal prism. Let's take a look at number 8. What kind of a shape do we have on number 8? Triangular prism. Okay. All right, let's highlight our bases for number 8. Go ahead. Let's highlight our bases. We're going to highlight our bases on all these questions, so highlight our bases. To put triangular prism, yeah? See, good. Okay, all right. All right, so then what is the, we're going to find our lateral area, right? What is the height of the solid? It's the distance between the 2 bases. It's the line that separates. Yeah, it's like a pole that holds those 2 bases apart. Okay, then we need to find the perimeter of one of the shapes of the bases. How do we find perimeter again? Okay, so we go 1 plus 1, 15 plus 8 plus. Oh, wait a second. Uh-oh.
This is a prank.
All right, we'll go on. I'll leave that one for you to do a little bit later. So there you go. You can just write down that little hint for you there. So. Okay, let's talk about cylinders. Here we go. Okay, the good news is the cylinder, because it's a prism, has a very similar formula set up for it, right? So we've got to find the lateral area, which is the side of the shape that is not the base. And then we find the area of the bases, and then we're good to go, right? So it should be pretty safe. And if you think about like a cylinder, like a can of food, and you unwrap that packaging, right? Like you would get like something like this, right? That would be wrapped around the cylinder, right? The lateral area, what would the area of this be? Well, it'd be height times base, right? Because it's a rectangle. Yeah? Okay. Why is it height times 2 pi r? No, we're not talking about the base. We're talking about the lateral area. This right here. I unwrapped it. If we're talking about height, if this is the height of the two-dimensional shape, why isn't this b base? Why is this 2 pi r? No, it's not volume. We're talking about a flat two-dimensional shape here, right? I'm looking for the area of this shape, right? Isn't it like two measurements multiplied, right?
Well, isn't 2 pi r like the circumference? And then so if it's times the height, it's just like adding like the height to it. Like if it's 2 pi r, like times the height.
Right, but how is this 2 pi r? John?
Because when it's wrapped, it's round.
Because it's wrapped around the can like that. Right? So if you think about this wrapped around the can like this, right? And then we unwrap it, that same distance right there is the circumference of the circle. It's like taking the circle and stretching it out like a belt like we did with that first one. And so that's why this distance here is 2 pi r, and this is our height. So that makes it really easy for us to find our lateral area. And then once we know our lateral area, we find our two bases again. Here's your lateral area. Here's your lateral area. Find two of the circles for your bases. And the cool part is we're going to make it easy. We're going to leave it in terms of pi. So we're not going to do the approximations. We're going to have our pi answers. All right, so let's do this first one. So this one right here. Is this, what is the height of this cylinder? 26. Again, it's the same idea. This is the distance that separates the two bases, right? And this 11 yards, what measurement is that?
Radius.
That's a radius because it's halfway through, right? Okay, good. So then our lateral area is just going to be 2 times pi times radius times height. But we just said that the radius is 11 and the height is 26. And so now we're just going to multiply those up. Yeah. All right.
Do you have to put like the pi right by the first parentheses? Just because that's the formula, or can you put like the 2 by because you're like,
Well, when we get to the end here, I'm going to want your pi at the end because usually when we write like 3x, we don't write x3, right? So we usually put the variable at the end. But as we're writing our formula out, I just write it like this because that's the way that the formula reads right here.
so we're doing it as like lateral area equals pi, and then 2 times 11 times 6. Is that fine? Or
It's
do you
okay.
want me to
It's the
write
same
it?
thing. It's fine. Okay, so then our lateral area, we're just going to multiply 2, 11, and 26. So what's 22 times 26?
500.
Okay, so our lateral area is going to be 572, and we're just going to say this for now. It's going to be 572 pi, right? Okay. Now, the area of our bases. So capital B base is going to be pi radius squared. So what is the radius again? All right, so we got 11. So 11 squared is what? 121. So this is going to be 121 pi, right? Okay. So then our surface area of our cylinder is going to be 121 times pi plus 572 pi. So we got 242 plus 572. No. 242 plus 572. 814 pi. Don't forget pi. Yards squared. No, pi isn't squared because pi is just a variable. It's just like an x. It's the unit of measure that's being squared, and so it's yards squared.
Like, even if there's 2 pi's, sometimes that would be
Right, because we're not multiplying them, we're adding them. So like if we had 2x plus 5x, we wouldn't get 7x squared. We would just get 7x. So here we have 242 pi plus 572 pi is 814 pies. A lot of pies. I like pie. Pie's good. Yes?
Like on our next test, if you want us to find the approximate answer.
No, I'm not interested in the approximate. I'm going to keep it in terms of pi. It's a lot easier. Then I don't have to hassle with people rounding weird. Okay, that was easy, right? Yeah, good. Find the lateral area, find the area of the two bases, put it together. All right, good. So I'll let you do this one on your own. So let's talk about number 11. Yeah, 11's a little weird. Okay. If the surface area of the box of cereal is 272 inches squared, find the length of the box. How about this? Why don't you try to set up a math problem with a variable or variables, whatever you think is necessary, using our, well, this is a rectangular prism, right? So we would use that formula. Using that, why don't you try to set up a math problem that would help us figure this out? See what you can do. Give it a shot. You're going to come up with your own math problem. See what you can do. You should have had something like that.
Yes.
Yeah? So in this case, we have the surface area, and we have two of the three other measurements. The one we're missing is this one. Okay, so then why don't you write out what you think the next level of work would look like? What would you do if you were going to do the next level of work? If this was a test and you were like, hey, I want to make sure that Mr. Marcus knows I know what I'm doing, and I'm going to make sure to answer that question well, what do you think it would look like? Go ahead, give it a try. I would like to see that. That's what I would like to see.
Mine was just mixed around.
Same thing with the earlier one, right? Those numbers can be in a different order. So, and then from here, you can start combining like terms and solving your equation. All right, go ahead and finish it up.
Yes.
So solving the equation, you should have come up with this. Does that sufficiently answer the question? No. It doesn't. What's the question asking? Find the length of the box, right? L equals 8. Like if I said, hey, what's the length of the box? You said L equals 8. That's not really a good full answer. How long is the box? It's 8 inches. What? Nothing, because it's a linear measurement. It's one-dimensional, right? Good? Cool? Okay. So 12 is kind of the same idea. So I'll tell you what, why don't you do 12 right now? Let's see how you do with 12. All right, give it a shot. All the way through. Okay?
You have a lot of faith.
All right, let's take a look, see how you do. Got a pretty good idea what we're doing?
Yeah.
Feel fairly confident with it? All right, you guys are out of here. Thank you very much. Again, if you didn't do your mathematicians on time, get them to me as soon as possible so that you don't miss out on that. I'll pick somebody really hard and really old.